Hi everyone. As I promised in the previous video, today we are going to discuss how to find depth of a foundation or depth of a footing. In the previous video, we discussed how to find size of the footing. That means in that one we discussed how to find the area of a footing and how to find depth and the width of the footing. In this video, now we are going to discuss how to find the depth of the footing. So this is the column. I will draw this footing. This is the column. And this is the footing. So this is a 3D view of this footing. This is the footing. We know all the structural load are bear rimmed by the footing or foundation. They are transit through the structural load to the soil. So this is the column and this is the footing. Now we are going to discuss depth of the footing. Imagine this is the ground floor level. In the previous video, we discussed how to find this area, how to find this length, how to find this width. Now we are going to discuss how to find the depth of the footing. This is the depth. This is the ground floor level, and we are going to discuss this level. I will say the depth of the footing as capital D. Now we are going to find this D. According to the Rankines formula, I am going to present you the Rankines formula. Rankines formula. According to the Rankines formula, you can say the depth of the footing, capital D, should be equal to P over W into 1 minus sine theta over 1 plus sine theta squared. Then I will explain these terms. D, depth of the footing, that's what we are going to find. P is the total structural load bearing from the foundation. We discussed in the previous videos also about this load, and I promise you I will present you another video how to find this structural load. But if you are a university student, they will provide this data, this structural load and all the things as given data. But if you are a civil engineering student, or if you are do your own works, then you have to find these structural work loads also. I will explain those things in another video. Okay, the P is the total structural load that is acting on the foundation. That is we called P. Then what is W? I told you. Um, the W is the density of the soil. According to the structures, according to the site, you can see the several kind of soils. So this is the soil that we are going to construct our footing. So this is the soil. Before we are going to construct our footing, you need to know what kind of a soil are there. Then you need to find the density. We called density as W. So the W is the density. Now the final question. We know the one. Now the final question, what is theta? The theta means I told you there is a soil. We need to investigate that soil. We can take some soil and we can put our soil in a pavement or in a plow. If we put that soil, we can see like it's like a cone. This is a 3D view that theta is equal to here. That means this is the angle of theta. Normally we call that this theta is equal to, we say, angle of repose. This theta is we can say as angle of repose, or we can say this one as internal friction of soil. So this is we call angles of repose or internal friction of soil. This is a variable. It's depend on the soil. The normally this depend in between 15 to 35 or something. Most probably is depend variable at in between 15 and 35. So that is the theta angle of repose. Now let's uh, find the depth of the footing. For the explanation, I will take P, the load as 400 kilonewton, and I will say the density as 18 kilonewton per cubic meter, and angle of repose theta is equal to, I will say, 30 degree. Now we are going to find the depth of the footing. So the depth of the footing should be equal to load over density. Load they called 400 kilonewtons, and the density 18. That's what we got for the explanation. 1 minus sine 30 over 1 plus theta is equal to 30 squared. Now you can simplify. So this d should be equal to 400 over 18 mean 22.222. 1 minus sine 30. Sine 30 is equal to half. That means 0.5. 1 sine 30 is half. That means 0.5 squared. So this d should be equal to 22.22 into 1 minus 0.5. That means 0.5. 1 plus 0.5. 1 plus 5 squared. You can use a calculator and you can find the answer. You may receive depth of this footing is equal to 2.46 meters. Why did I put meters? Because I used all the units with SI units. Then the final answer also will be with the SI units. The SI units for the length is meters. That means we found 2.46 meters should be the depth. Then normally we can say this one as 2.5 meters. We can say 2.5 meters. Okay. That means the depth of this footing should be equal to 2.5 meters from the ground level. This is the way to find the depth of the foundation. In another video, I will show how to find this structural load, how to find this density of the soil, and how to find this theta angle of repose. That's all for today. We will meet with another video. Thank you.